Yo, what's poppin', my guys? You are feeling cool? I know you do. Today, I'll be showing you something very cool that very few people actually know about. Like, I would say like 90% of people, or 99%, don't know about this life hack. Like, you literally cannot live without this. This is actually something what I'm about to show you, alright? And, so, today, you want to know what it is? Well, today I will show you how to Google. Let's get started. First of all, we're going to want to open a new tab. First, we're going to type in the link I left for Google. Ready? Google. You probably don't have to type all that out because it'll autofill. Or else, if you don't use Google, you're like more of a Safari person, then maybe not. But still, you enter it, and boom. Now, this is the actual insane part. I'm going to show you how to Google. But first, a word from our sponsor. This video is sponsored by the Help a Bro Out Foundation. Founded by Hatifa Logan, this program is very useful for learning new things, giving you answers, and helping you study quickly for a test that you are totally unprepared for. Now, I know that learning is boring to some, but for people that want to learn, here's a free sample lesson about states of matter showing what this program can provide. Hello everyone, Gab Murte of the Help a Bro Out Foundation here, on a lesson about states of matter. Most of us know about the three main states of matter, that being solids, liquids, and gases. We can easily distinguish with our minds what makes up what a solid, liquid, and gas is. Solid is a hard object, a liquid is a wet substance that flows, and gases are invisible things in the air. However, it's actually more complicated than that. To see what I mean, we'll have to get down to the small particles which make up these things. Scientifically, any object's state of matter is determined by its particles and how they interact with each other. For example, an object is a solid if its particles have a strong bond with each other, with very limited movement between the particles. An object is a liquid if its particles are loosely connected, allowing for particles to move a decent amount and sometimes slip away from each other. A gas has very low connection or bonds between particles, allowing for particles to move all over the place and slip away more often. Because of these properties, solid is typically described as having a definite shape and volume, meaning a shape and volume that doesn't change, and a liquid is defined as having a definite volume but not definite shape, and a gas has neither a definite shape nor volume. More specifically, a solid will not change shape or volume if untouched, while a liquid will change its shape to the shape of its container, but not its volume if untouched. And both a gas's shape and volume will be the same as the volume and shape of its container. With this new information, you may now be wondering, what exactly are these particles, and how do they act? To start, particles are tiny things that make up all matter. They can consist of ions, atoms, molecules, or more. Particles, as stated by the kinetic molecular theory, will always move in a random motion in all directions. Every particle has a pull on it that makes it so that when particles come close together, the particles will start to attract each other. Depending on how close or far a particle is from another particle, the attraction between them will either be very strong or very weak. A particle's motion and pull on each other go hand in hand. For example, if the motion of particles are decreased, the force and bond between them will grow stronger. On the other hand, if the pull of particles are increased, then the motion will decrease. Therefore, the closer particles are to each other, the stronger pull, and therefore the less the motion. So a solid is an object with low motion and strong pull between the particles, liquid less pull and more motion than a solid, and gas even less pull and more motion than a liquid. This information is helping me get to another point, which is about how objects change states of matter, and how many states of matter there even are. But let's still go through a few more things before you reach that point. Right now, let's talk about gas laws. Boyle's law, invented by Robert Boyle, is a law that states that as long as the temperature of a gas is held constant, the pressure of a gas will decrease if its volume increases, and the pressure will increase if the volume of a gas decreases. Using the scientific definition of pressure, which is force applied per unit of area, decreasing the volume of the container which holds a gas will increase its pressure and therefore cause the particles of the gas to move faster. Once again, going back to kinetic molecular theory, another property of particles is that when particles collide with each other or the walls of its container, the pressure of its container increases. The kinetic energy within the particles are released into the container once they collide with each other or the walls of the container, and a container can only hold so much energy. The relationship between an object's volume and its pressure, if temperature is held constant, is exponential. Another important gas law is Charles' law, which states that the volume of a gas will increase if its temperature is increased, as long as pressure is held constant. This means that as the temperature of the particles increase, the pull between them will decrease, causing them to spread out and therefore increase the space which they cover, or the volume. This means that any container that is holding the gas will increase in volume, if it is possible to do so. If it's not possible, then the pressure within the container will build. Unlike Boyle's law, however, the relationship between the temperature and the volume of a gas is linear. Now, before we discuss what any of these gas laws have to do with states of matter, we'll discuss one more key concept that is important to know: temperature. Temperature is what we commonly know as a measure of how hot or cold something is, and that's basically what it is, but it also has a more literal and scientific meaning to it, which is the average kinetic energy of a group of particles. Furthermore, a lot of people get confused with temperature and thermal energy, thinking they're the same thing. Though the relationship between thermal and energy and temperature are pretty strong, they are two different things. While temperature is the average kinetic energy in a set of particles, thermal energy is the total sum of kinetic and potential energy in particles. This means that if the potential energy is increased but not the kinetic energy of the particles, the thermal energy will rise but not the temperature. Now that you have all of this information to work with, let's answer these two big questions. How do objects change states of matter, and how many states of matter are there? Because what state of matter an object is depends on the movement and strength of the attraction between the particles. If something were to cause the particles of an object's movement to start behaving like a different state of matter than it originally was, then it would technically be turned into a new state of matter. This can happen to an object by big changes in temperature or pressure. This is the case for ice, where if its temperature is increased, this means that the average kinetic energy of the particles within the ice will increase, which, if increased, could cause the particles to behave more like a liquid and therefore make the ice turn into a water. This is applicable for almost every object, and it's similar to what Charles' law states, as increased volume means more space between particles, and therefore also less attraction between them. Despite this relatively simple connection, when it comes down to how many states of matter there are, and if certain states of matter are actually their own state or just extensions or combinations of other states of matter, is another debate. In fact, it is not unanimously agreed which things are even new states of matter, or if they're just a variant or a combination of one of the three main ones. However, there is one state of matter that is unanimously agreed by a scientific community to be a fourth state of matter. This state of matter, known as plasma, is most commonly found of space, and consists of particles that are heated up so much that the electrons separate from the atoms, making up the particles, and begin to move freely. Besides plasma, however, many other things such as a Bose-Einstein condensate, a quark-gluon plasma, or a time crystal are too complex to make and are almost never found in space to be considered a definitive state of matter. For example, a quark-gluon plasma is just a plasma heated up to an insanely high temperature, which causes the quarks within the neutron and protons of the particles to break free and flow around further, allowing for it to be even more free. However, This insane temperature, which is approximately around 4 trillion degrees Celsius, must be held constant for the Clark-Gluon plasma to continue existing, as if it is even slightly cooled down below this temperature, everything will reform back to its original plasma state, although as a somewhat crystallized form of it known as a hadron. Because these other states of matter are nearly impossible to create and are almost never found in nature, they're often not considered amongst the four states of matter. Hello guys, so now I'm gonna show how to do it. Alright, that's gonna be crazy. Watch. Google. That's crazy, bro. Yeah, that's it.